The Vigenère cipher is a polyalphabetic substitution cipher that encrypts text using a repeated keyword. It improves upon simple substitution ciphers like the Caesar cipher by applying multiple shifts to different letters in the plaintext, making frequency analysis more difficult. Instead of shifting every letter by the same amount, the Vigenère cipher shifts each letter based on a keyword. Each letter in the keyword determines the shift amount for the corresponding letter in the plaintext. The encryption process starts by choosing a keyword. For example, if the keyword is Lehman and the plaintext is attack at dawn, the first step is to repeat the keyword until it matches the length of the plaintext. The keyword Lehman repeats to become lemon, lemon, lemon. Next, each letter in both the plaintext and the keyword is converted to numbers where A equals 0, B equals 1, Z equals 25. For example, the letter A corresponds to 0, T corresponds to 19, and L corresponds to 1211. The numbers corresponding to the plaintext attack at dawn are 0, 1919, 02, 10, 193, 022, 13. The numbers corresponding to the repeated keyword lemon, lemonly are 11, 412, 14, 13, 11, 412, 14, 13, 11, 4. Once the plaintext and keyword have been converted into numbers, the encryption process shifts each plaintext letter by the corresponding key letter using modular addition, mod 26. Each plaintext number is added to the corresponding key number, and the result is taken mod 26 to ensure it stays within the range of 0 to 25. The calculations for the ciphertext are as follows. 0 plus 11 equals 1119, plus 4 equals 23, 19 plus 12 equals 31. 31 மாட்டு 26 சமம் 5 சுழி plus 14 சமம் 2 plus 2 plus 2. 13 equals 15, 10 plus 11 equals 21. 0 plus 4 equals 4. 19 plus 12 equals 31. Arrow 31 mod 26 equals 5 3 plus 14 equals 17 0 plus 13 equals 13 22 plus 11 equals 33. Arrow 33 mod 26 equals 7 13 plus 4 equals 17. The resulting numbers are 11 23, 5 14, 15 21, 4 5, 17 13, 7 17. Converting these numbers back into letters gives the ciphertext LXFOPVEFRNHR. This means that encrypting attack at dawn with the keyword lemon produces LexFopVegnere. The decryption process reverses these steps to recover the original plaintext. First, the ciphertext and keyword are converted into numbers using the same A equals 0, B equals 1, Z equals 25 mapping. The ciphertext LXFOPVegnere converts to numbers as follows: L for 11, X 23, F 50, 14, P 15, vein 21. E equals 4F equals 5, R equals 17, N equals 13, H equals 7, R equals 17. The keyword Lehman Lemonly is converted to numbers again. L equals 11, E equals 4, M equals 12, O equals 14, N equals 13, L equals 11, E equals 4, M equals 12, O equals 14, N equals 13, L equals 11, E equals 4. To decrypt, each ciphertext letter is shifted backward by the corresponding key letter using modular subtraction, mod 26. The calculations are as follows. 11 minus 11 equals 0. 23 minus 4 equals 19.5. Minus 12 equals negative 7. Mod 26 equals 1914 equals 0.15. Minus 13 equals 2, 21. Minus 11 equals 10. 4 minus 4 equals 0.5. Minus 12 equals negative 7. Minus 7 mod 26 equals 1917. Minus 14 equals 313 minus 13 equals 0.7 minus 11 equals negative 4. Arrow negative 4 mod 26 equals 2217. Minus 4 equals 13. The resulting numbers are 0, 19 19, 02, 10 0, 19 3, 0 22 13. Converting these numbers back into letters gives the original plaintext "Attack at Dawn." The Vigenère cipher is stronger than the Caesar cipher because it uses multiple shifts rather than a single shift. In a Caesar cipher, every letter is shifted by the same amount, making it vulnerable to frequency analysis. The Vigenère cipher uses different shifts for different letters, making it harder to detect patterns. However, the Vigenère cipher has weaknesses. One major weakness is that if the keyword is too short, patterns emerge in the ciphertext. An attacker can find repeated sequences in the ciphertext and use the Kościuszki examination to determine the keyword length. Once the keyword length is known, the ciphertext can be split into separate Caesar ciphers. Each letter in the ciphertext that corresponds to the same keyword letter can be analyzed separately using frequency analysis. The Friedman test, also known as the index of coincidence, can also help determine the key length by analyzing letter distribution patterns. Once the key length is determined, the ciphertext can be divided into groups based on the keyword length. Each group is then treated as a separate Caesar cipher, making it easier to decrypt. For example, if the keyword is Lehman, 5 letters long, the ciphertext can be divided into 5 separate Caesar ciphers. If the ciphertext is Lex Fop v FRNHR, then the letters that were shifted by L are LPR, the letters shifted by E are XVN, the letters shifted by M are FH, the letters shifted by O are OFR, and the letters shifted by N are PN. Each of these groups can be solved individually using Caesar cipher techniques,